The very good morning. The good morning for everyone. Actually, my mobile display is gone. I have purchased a new mobile and also got a display for that old mobile also. Even my this effects also damaged. That's why I stopped YouTube class. I don't know. I will be busy whenever I am free. I'll be much busy, but whenever I will be free, I will keep on doing these YouTube classes, and I will just upload it in the YouTube. I will do the videos. Actually, some light inset is also is not good in this room. I will try to vacate this room after uh, April or March, in the April first week. And one more thing, actually the practical classes have started for 12th CBSE and also PU as well as both, for both. ಒಂದು ರಿಕ್ವೆಸ್ಟ್, ನಾನು ಮೊನ್ನೆ ಫೇಸ್ಬುಕ್ಕಲ್ಲೆಲ್ಲ ಹಾಕಿದ್ದೆ. ನಾನೆಲ್ಲ ಗೌರ್ಮೆಂಟ್ ಕೆಲವು ಗೌರ್ಮೆಂಟ್ ಕಾಲೇಜಲ್ಲಿ ಕೆಲಸ ಮಾಡ್ತಾರೆ ಗೌರ್ಮೆಂಟ್ ಲೆಕ್ಚರರ್ಸು ಪ್ರಿನ್ಸಿಪಲ್ಸ್ಗೂ ಕೂಡ ಹೇಳಿದ್ದೀನಿ. ಪ್ಲೀಸ್ ಗಿವ್ ಮಾರ್ಕ್ಸ್ ಫಾರ್ ಗೌರ್ಮೆಂಟ್ ಕಾಲೇಜ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಬಡವರ ಮಕ್ಕಳು, ಹಳ್ಳಿ ಗ್ರಾಮೀಣ ಮತ್ತು ಬಡವರ ಮಕ್ಕಳು ಬೆಳಿಬೇಕು. ಸೊ ಗ್ರಾಮೀಣ ಮಕ್ಕಳು, ಸರ್ಕಾರಿ ವಿದ್ಯಾರ್ಥಿಗಳು, ಸರ್ಕಾರಿ ಕಾಲೇಜಲ್ಲಿ ಓದ್ತಿರೋ ವಿದ್ಯಾರ್ಥಿಗಳು ಮುಂದೆ ಬರಬೇಕು. ಸೊ ದಯವಿಟ್ಟು ಮಾರ್ಕ್ಸ್ ಕೊಡಿ. ಸ್ಟೂಡೆಂಟ್ MT ಪೇಪರ್ ಕೊಟ್ಟರು ಕೂಡ ಏನಾದ್ರು ಸ್ವಲ್ಪ ಬರೆಸಿ ಏನೋ ಒಂದು ಮಾಡಿ ಮಾರ್ಕ್ಸ್ ಹಾಕಿ. ಕೆಲವು ಯಾಕೆಂದರೆ ಬಿಕಾಸ್ ಇನ್ ಮೆನಿ ಆಫ್ ದ ಪ್ರೈವೇಟ್ ಕಾಲೇಜಸ್ ಸ್ಟೂಡೆಂಟ್ ಏನೂ ಬರೆದಿಲ್ಲ ಅಂದರೂ 29-30 ಕೊಡ್ತಾ ಇದ್ದಾರೆ ಮಾರ್ಕ್ಸು. ಕೆಲವು ಎಕ್ಸಾಮ್ಗೆ ಅಬ್ಸೆಂಟ್ ಆಗಿರ್ತಾನೆ ಸ್ಟೂಡೆಂಟ್, ಬೇರೆ ದಿನ ಕರೆಸ್ಬಿಟ್ಟು ಬರೆಸಿ ಇಲ್ಲ ಮನೆಗೆ ಪೇಪರ್ ಕೊಟ್ಟು ಬರೆಸಿರೋ ನಿದರ್ಶನಗಳು ಉಂಟು ಪ್ರೈವೇಟ್ ಕಾಲೇಜಲ್ಲಿ. ವೈ ಐ ಆಮ್ ಆಸ್ಕಿಂಗ್, ಒಬ್ಬ ದೇಶದ ಸಾಮಾನ್ಯ ರೈತನ ಮಗ ನಮ್ಮ ದೇಶದ IIT ಕ್ಯಾಂಪಸಲ್ಲಿ ಓದಿದ್ರೆ, ಯಾವುದಾದ್ರು IIT ಕ್ಯಾಂಪಸಲ್ಲಿ ಓದಿದ್ರೆ ಅವಮಾನ ಆಗುತ್ತೆ ಆ ದೇಶಕ್ಕೆ. ಸಾಮಾನ್ಯ ಒಬ್ಬ ರೈತನ ಮಗ ಓದಿದ್ರೆ ಎಷ್ಟು ಸರ್ವೆ ಮಾಡಿ ನೋಡಿ, ಎಷ್ಟು IIT ಕ್ಯಾಂಪಸಲ್ಲಿ ನಮ್ಮ ರೈತರ ಮಕ್ಕಳು ಓದ್ತಾ ಇದ್ದಾರೆ ಅಂತ. ಓದಬಾರ್ದ ಅಂತ ನನ್ನ ಪ್ರಶ್ನೆ. ದಯವಿಟ್ಟು ಮಾರ್ಕ್ಸ್ ಕೊಡಿ. ಪ್ಲೀಸ್ ಗಿವ್ ದ ಮಾರ್ಕ್ಸ್ for in practical exams. So today I will do this, that earlier I was doing that electromagnetic induction. Today I will do that energy stored in a inductor, motional EMF derivation, energy stored in a inductor derivation, motional EMF derivation, and the definition of 1 Henry. How to define that 1 Henry. After that the expression for self inductance of a coil and expression for mutual inductance of a coil. Maximum they will ask for 2 marks. Write the expression for self inductance of a coil and define the terms. The derivation is not there now. Right now it has eradicated, deleted. That is self inductance and mutual inductance of a coil. Expression, only expression, and writing the expression and mentioning the terms is there. And applications of eddy currents, definition of eddy currents, and what are the uses or applications of eddy currents. I will discuss that much today. So energy stored in a inductor. Energy stored in a inductor that will actually start from diagram is not there for this derivation. Usually for 5 marks derivation, how to derive that means, how to the procedure, how to do that derivation 5 marks means, first we have to write the diagram. Without whenever derivation came for 5 marks question, sometimes without derivation if you have done means they will deduct 1 marks. So derivation and explanation. In that derivation, what will be there? The diagram is most required for 5 marks derivations. The assumptions and considerations, what and all we have considered to derive the equations, that assumptions will be there in that diagram. And minimum by using 2 or 3 lines we have to explain about the diagram. We need to explain about the diagram, what and all we have considered, how to derive that equation. So but for this is actually maximum for 3 marks they will ask this derivation. Diagram not there for this derivation, diagram not there. Just I will start from the mathematical equations of how it has started. So energy stored in a inductor. So the derivation is energy stored in a inductor. So this derivation is actually best suitable for 3 marks. Maximum they will ask for Maximum they will ask for 3 marks. So we can start this derivation from the equation. We know that power is equal to V into I. Actually, this equation will, derivation will start. We know that P is equal to V into I. This equation. So where P means power, the rate of doing work. Power is the rate of doing work. But it will this potential difference or electric potential will almost not exactly in open circuit and closed circuit will come. How this equation came means how to take that equation. It will start from here. I into E into I, where E is EMF and I is current. Power P is equal to V into I. Many equations or forms are there. Equations for that power P is equal to V into I. The power is the rate of doing work, dW by dt, that is equal to small letter E into I. From there we will start that this derivation, dW by dt is equal to E into I. So I will start from there only. So we know that in exam you can write that, or even if you have not written means also no problem. No problem. Directly you can start from here. So we know that WKT means we know that dW divided by dt, that is equal to small letter E into I. Small letter E into I. Now this is the small amount of work done. This is the small amount of work done. So further in the last class, previous class, I have derived that we know that E is equal to, you can write here only, no problem. This is this are all related to derivation only. This are all related to derivation only. Therefore, we know that. So, but we can write here, but E is equal to small letter E is equal to L times of I times of di divided by dt. Substitute this value of E, you can substitute here. You can show the RMRs like this in exam, no problem, nothing will happen. So that equation will become dW divided by dt, that is equal to, so in place of E I will write a small letter, I will write in place of the capital L into I into di divided by dt. dW by dt, that is equal to L into I into di by dt, where L is inductance, self-inductance, I is current, di by dt. So how the current will change with respect to time, that is actually di by dt. So in this equation actually this dt and dt will get cancelled. This dt and dt will get cancelled. What is left you can write down. So what is left here, dW, that is equal to L times of I times of di by L times of I times of di. This is actually the small amount of work done. This is actually the small amount of work done. To get total work done, you can integrate this equation on both sides. To get total work done, integrate this equation, dW is equal to integration of dW, that is equal to integration of L into I into di. Integration of dW, that is equal to integration of L into I into di. So this dW is actually the small amount of work done. Why we are supposed to integrate? Why we are supposed to integrate? In many of the derivations it will come. Initially we will take small amount of work done or anything, small amount of quantity. To get total quantity or total work done or anything, whatever it may be, not only the work, in some other derivations also it will come. So we have to integrate that equation, then we will get the total work done or any other physical quantity also, the total quantities. So now we can integrate this equation. So if we have integrated dW, this integration and differentiation both are actually vice versa or reverse processes. Understood? In mathematics it will come. One day I will explain that integration and differentiation also. So now here, so integration of dW, that is equal to integration of L into I into di. So this dW, you have, if you have integrated this dW, then it will come, I will write calculated W, because it is the total work done. Small integration of dW, that is equal to, if you have integrated, capital W will come. So this is actually, that is in the form of this integration of L into I into di. In mathematics, one standard formula is there for this, both for differentiation and integration, standard formulas are there. So I will write here. We know that the standard. What is the standard formula? Integration of x to the power of n into dx, that is equal to x to the power of n plus 1 divided by n plus 1. This is the standard formula actually. Integration of x to the power of n into dx, that is equal to x to the power of n plus 1 divided by n plus 1. That is actually the standard formula. So by compare these two equations, or I will write here integration of L into I into di. Here, sorry, L is constant actually. No, we are not supposed to take that L is a constant. Inductance is constant. Inductance is constant. Only further I will rewrite this equation. L times of integration of I into di. L is constant. You can just take outside. Now this equation, it is in the form of x to the power of n into dx. I will take here integration of what is this, I into di. Integration of I into di, that is equal to, here power, if here power anything is not there means here power 1 will be there. In place of n nothing will be there means it understood that there 1 is there. Now according to this formula, in place of x I is there, in place of dx di is there, in place of n 1 is there. Now according to this formula, it will become I to the power of 1 plus 1 divided by 1 plus 1. Now it can be written as 1 plus 1 means 2, I square divided by 2. I square divided by 2. Therefore, in place of this integration of I into di, in place of this integration of I into di, in place of this I into integration of I into di, directly we can write I square divided by, according to that integration, directly we can write I square divided by 2. Therefore the equation will become W is equal to L times of I square divided by 2, or in many of the textbooks they have written this W is equal to half L I square. Further, W is equal to half L I square. Further, work done always it will store in terms of energy. Work done always will store in terms of energy. So we know that work done will always store in terms of energy. So according to this, W is equal to, it is possible to write W is equal to U. Therefore, at last finally the equation will become U is equal to half Li square. U is equal to half Li square. This is the expression for energy stored in a inductor. Once again I will explain. Actually something I have derived this equation very speedily because I am almost 10 11 years experienced. So therefore once again I will slowly explain. This topic is actually for slow learners. Slow learners means the students who don't know, they will feel that they are feeling very scared. I don't know anything. I want minimum passing marks. After passing the PU or 12th CBSE, no, I am much aware, much scared, afraid of about this physics. I will just do BS and MSc. I will become teacher or lecturer. For the such kind of students, this topic is very easy topic. Only one or two derivations are there. Remaining all just like biology question and answers. That's why I have selected this topic. It will become helpful for rural side students. Therefore, so the students who will feel very much scared, I don't know anything what to do. The exams came almost approached very fastly, the days are approached. So such kind of students, you can select this topic, electromagnetic induction and dual nature of matter and radiation and semiconductors. One more topic is there, dual nature of matter and dual nature of radiation and matter, this EMI. So easy. Apart from that, some important questions are there. I will say the common questions. One day I will discuss. Once again, I will explain slowly. We know that you can start from here. We know that because the slow learners actually this derivation they will feel tough because here integration will come. Some rural students they don't know about that integration and derivation. So that's why. But you can practice it very easy derivation. This one actually. So you can start from, we know that dWo is equal to, we know that dWo divided by dt is equal to small letter e into I. Actually this will come from power P is equal to V into I from there. But this and all, what is there here, this much no need to write in exam. This is just for understanding purpose. What I have done this side, only derivation this much and this much is enough. Only this step, only two this one and this column what is there and this column, this much is just for your understanding purpose, no need to write the exam. If you have written also, no one will question. Okay, if you have written also, no one will question. So we know that you can start from dw divided by dt is equal to small letter e into I, but we know that in the last class I have derived this, how this equation came. Small letter e is equal to L into I into di divided by dt. We can substitute this value of e here. We can substitute this value of small letter e here. Then dw divided by dt, that is equal to L into this, in place of e you can write L times of just e value here, only e value this much actually. L times of di by dt. I will be usually in this equation only. I will be in this equation only. This is the value of small letter e. What is the small value of small letter e? L times of di by dt. Actually, it is. I will be in the. It will come from this equation only. E value small letter e is equal to L times of di by dt in case of self inductance. In case of mutual inductance, it is m times of di by dt. I will write this equation once again here. Actually, much gap is there. So, what is the value of small letter e? Small letter e value L times of di divided by dt. So in the middle I have inserted this I, because if I wrote it in the last means somewhat it to practice it will become difficult, that's why. So again here, so just substitute this value of e here, cancel dt and dt will gets cancelled. What is left you can write down here. So after that, this is actually the small amount of work done. To get the total work done, you can integrate the equation on both sides. Limits also is there, but here actually the limits from 0 to w you can take in the LHS. In the RHS actually from 0 to I, they will take, but here no need to mention upper limit minus lower limit. It will become very lengthy process. It understood initially the small current, after that large current, like that. So you can just integrate, the integration of dw is w, integrate the RHS also. L is constant, you can take outside. L is constant, you can take outside. What is left? Integration of I into di. This integration of I into di value is I square divided by 2 according to integration. So just you can replace this term, what is integration of I into di, replace it and substitute I square divided by 2, L I square divided by 2. Then W is equal to U. Always work done will store in terms of energy, whatever it may be. Sometimes electric energy, magnetic energy, sometimes potential energy. Based on that situation, work done will store always in terms of energy. Therefore, W can be written as U. Therefore, at last, finally, U is equal to half L square. That is the derivation of that energy stored in a inductor. Next, in the same way, one more important derivation is there here, best suitable for 3 marks only. So what is that? Motional EMF derivation. Motional EMF. Sometimes they will ask a question also, what is the, for 1 marks question they will ask, what is the define motional EMF, or what is motional EMF? What is motional EMF or define motional EMF? Like that also they will ask the question. Motional EMF definition also is there, and derivation also is there. So I will now derivation of that motional EMF. Derivation of that motional EMF. So this derivation is also best suitable for 3 marks. Best suitable for 3 marks only. So actually for this one small diagram is there. I will write that small diagram. So actually here a uniform magnetic field will be there. This star marks indicates, I will write somewhere this star marks. What are these star marks means? These are actually the uniform magnetic field. It represents the star marks. Actually it will represents the star marks will represents the uniform magnetic field. The star marks will represents The star marks will represent the uniform magnetic field. Whenever a conductor is moved in a uniform magnetic field, whenever a conductor, you can consider one conductor. This is actually conductor of length L, of length small letter L, conductor of length small letter L. I will denote it by capital small letter by red ink. So you can take this denote this conductor as PQ. Let PQ is the conductor. You have to explain about this diagram also. Consider a conductor of length small letter L is moved in a uniform magnetic field through a distance. This conductor, now I will move this conductor from here to here. I will write by dotted lines. I will write by dotted lines from where to where we have moved that conductor. From where to where we have moved that conductor. To indicate that, I will just denote it by the dotted lines. From here to here, through a distance dx. Through a distance, small distance dx. Let the conductor has moved in a uniform magnetic field through a distance dx. Understood? Through a distance dx, the conductor has moved from here to here. Now, in this time, during this time, whenever a conductor is moved in a uniform magnetic field, some kind of EMF itself will induce in this conductor. Whenever a conductor is moved in a uniform magnetic field, some amount of EMF will get induced in that conductor. That is called as motional EMF. The name itself indicates motional. Motion means the conductor is moving in a uniform magnetic field. The conductor is moving in a uniform magnetic field. Then what is the correct definition for this motional EMF? Sometimes they will ask for 1 mark question. What is motional EMF or define motional EMF? The correct definition is the current induced in a conductor. The current induced in a conductor whenever it is moving in a uniform magnetic field. You can say like that. Or not current, EMF, sorry. The EMF induced in a conductor which is moving in a uniform magnetic field. The clear definition you can, I will write here. The clear definition you can write. What is that motional? What is motional EMF? The question came means the EMF induced in a conductor which is moving in a uniform magnetic field. The EMF induced in a conductor which is moving in a uniform magnetic field, that is called as motional EMF. I will write here the EMF induced. What is motional EMF? The EMF induced in a conductor. The EMF induced in a conductor which is moving in a uniform magnetic field. Here one more will come, eddy currents. That is actually varying electric flux or non-uniform magnetic field will come, which is moving in a uniform magnetic field. That is called as motional EMF. The EMF induced in a conductor which is moving in a uniform magnetic field, that is called as motional EMF. Speedily I will derive this equation. After that, because that video 30 minutes or maximum 40 minutes it will take, I think. After that, once again I will explain. So you can explain about this diagram. Consider a conductor of length small letter L is moving in a uniform magnetic field. Consider a conductor of length small letter L is moving in a uniform magnetic field. Let the conductor is a PQ. We can say that one also. So after that, let the conductor has moved through a distance small letter dx in a uniform magnetic field. Let the conductor has moved through a distance dx in a uniform magnetic field. Now we know that some amount of EMF will induce in that conductor, that is called as motional EMF. How to derive this equation? You can start this equation. You know that Faraday's second law. What is the Faraday's second law? So we know that WKT means we know that. So small letter E is equal to d pi divided by dt. E is equal to L times of d pi divided by dt, that is called as, you can start from Faraday's second law. What is that Faraday? E is equal to d pi divided by dt. This is the Faraday's second law. B, it understood that B, if you are not written outside, understood. Here it is related to magnetic field. What is this field? This star marks, that is not electric field, that is star mark is magnetic field. Now E is equal to d pi divided by dt. You can start from this equation from Faraday's second law. So now we know that further we know that pi is equal to B into A. Further, pi is equal to B into BA cos theta will become magnetic flux. Pi means here magnetic flux, not electric flux. Not electric flux here. In this equation, in the first topic, it will come electric charges and field. There, electric flux will come. Electric charges and field. Pi means pi E and pi B. You can pi E means electric flux. Pi B means magnetic flux. So pi B is equal to BA cos theta. That cos theta will get vanish whenever depends upon that theta. Understood? So when theta is equal to 0 degree, the cos value 1 actually. Theta is equal to 0 degree, the cos value is 1. When theta is equal to 90 degree, 1 0 infinity, it will get a 0. It will become 0. Leave it. Depends upon the situation of theta. It will. But actually here we have to show that here theta value is 0. Actually there is no perpendicular. Parallelly we are moving that conductor with a uniform magnetic field. Theta will become 0 only, we have to consider here. So now further, what is area? B means magnetic field, so A means area. So this area we can calculate, depends upon this situation. So how much area it has covered actually? How much area it has covered actually? So this actually, see this it looks like a rectangle or a square. So sometimes depends upon the diagram. So whatever it may be, we will calculate how we will calculate area, how much space it has occupied, how much what is the area, this L into dx base into height. So through distance dx we are moving along in this direction. So here this is the height L. So you can just multiply L into dx, so you will get that area. So the value of area here L into dx is the value of area. Substitute that A value in this pi. So substitute here this A value, you can write the RMS like this in exam, no problem. So therefore now pi B is equal to what is this B into L into dx. This is the value of pi B. Further you can substitute this pi B value here. Then the equation will become E is equal to d by dt times of what is this pi B value? B into L into dx. Now in this equation, so it looks like a differentiation, d by dt times of B into L into dx. Here magnetic field is constant because this is uniform magnetic field. And L is also constant. Length of the conductor will never change. You can move from here, you can move from here also in a uniform magnetic field. You can move in any from where to where, wherever you can move that conductor in a uniform magnetic field. Length is fixed, length of the conductor will not change. Magnetic field is also constant here because this is uniform magnetic field. Then what is varying? Only the thing is variable, distance. Distance is varying. How we are moving, from where to where we are moving, only distance will vary. So therefore E is equal to d by dt times of BL into dx. You can take outside that B into L. You can integrate only that. You can take outside that B into dl. You can differentiate it. Sorry, not integrate. You can differentiate it. Here small letter E is equal to B into L is constant. You can take outside, remaining dx divided by dt. So here actually you don't think like, sir, wow, what is this here? One here d only, d here d, it should be d square x, no, double derivative, and don't think like that, please, okay? Because or else you can take, we are moving to, you can take this as a x only. You can take this as a x only, no problem, nothing will happen. Then directly it will come dx by dt. So in the 11th standard we have studied further what is this dx by dt. So I will write two things here. I can remember these two also. In the 11th standard, in a motion in a straight line, in physics, that topic we have studied. As the two equations are very important equations. Remember this: acceleration is equal to dv divided by dt. whereas velocity is equal to dx divided by dt. According to that equation, this dx by dt can be written as that dx divided by dt. This dx divided by dt can be written as velocity. Therefore, at last the final equation will become E is equal to B into L into V. This is the expression for motional EMF. This is the expression for motional EMF. Understood? The very easy derivation. The very easy derivation. This one. Just put this diagram. Right by your own words. You can write one or two lines explanation. We can start from this Faraday's second law. E is equal to d pi b divided by dt. So pi b is equal to b into a. So we know that area, how to calculate it? You can calculate area from the diagram. You can substitute here. Area is equal to L into dx. Substitute this area value in this matrix flux equation. Again substitute this pi value here. So it will become like this BL dx. Pi, this is the pi b value. We can substitute here. E is equal to d by dt times of this pi value BL into dx. B and L is constant. Take outside B and L you can take outside. So what is left here? Dx divided by dt. This dx divided by dt can be written as velocity. V is equal to dx divided by dt. Therefore, it is E is equal to BLV. Without actually preparation, I have done this one. Just early morning I woke up. ಇವತ್ತೇನಾದ್ರು ಮಾಡಲೇಬೇಕು ಕ್ಲಾಸ್ನ ಅಂತೇಳಿ ಅಟ್ ಎನಿ ಕಾಸ್ಟ್ ವೀಕಲ್ಲಿ ಒನ್ ವೀಕಲ್ಲಿ ಇದ್ದೇ ಇರುತ್ತೆ ಮಿನಿಮಮ್ 2 ಕ್ಲಾಸ್ ಅಟ್ಲೀಸ್ಟ್ ಆರ್ 3 ಐ ವಿಲ್ ಡೂ ಇಟ್. ಎಷ್ಟೇ ಕಷ್ಟ ಆದ್ರೂ ಎಷ್ಟೇ ಬ್ಯುಸಿ ಇದ್ರೂ ಕೂಡ ಮಾಡ್ತೀನಿ. ಇವತ್ತು ಕ್ಲೀನಾಗಿ ಪ್ರಾಪರಾಗಿ ಹ್ಯಾಂಗ್ ಮಾಡಿದ್ದೀನಿ ಮೊಬೈಲ್ನ, ಬಿದ್ದು ಡಿಸ್ಪ್ಲೇ ಹೊಡೆದೋಗ್ಬಾರ್ದು ಅಂತೇಳಿ. ಸೊ ಐ ಹೋಪ್ ದಿಸ್ ಮೆಥಡ್ ಈಸ್ ವೆರಿ ಯೂಸ್ಫುಲ್ for this motional EMF. I will in the one more video I will do that